Today we're doing medium problem 1570 dot product of two sparse vectors. Given two sparse vectors, compute their dot product, implement class sparse vector. So that class takes object with nums and then we do dot product with another. It has mostly 0 values. You should store efficiently and compare and compute dot product between two. What if only one of them is sparse? Well, okay, so whole point is that dot product is first position times first position plus blah blah. So if there is 0 at some position in either of them, we ignore them, right? So we are only interested in non-zero positions, which we can store in whatever hash map, right? Self, let's call it like, I don't know, nums is, let's do like something like this, right? And then n1, n2, self nums, that's nums. If len n1, n2. Basically what this does is, since we iterate only over non-zero positions, we want to iterate over less positions, right? We don't care about other positions because no matter what's in the other one, it's still gonna be 0, right? So we want to iterate over the one that has smaller number, right? So we do like nums is self nums if len self nums under len back nums else back nums, right? And then we go, oh, I need both of them. And then we do like index num, we need some sort of an answer in n1 okay, and then we do n1 index times n2 index if index in n2 else 0, return ans. Boom, should work and should be optimal. Space wise I'm beating 5% and time wise also. You have to be kidding me, bruv. That's ridiculous. Wow. Wow. Okay, well, something's wrong. I did that, but non-efficient array approach. Hash table. Index value pairs. That's interesting. Two pointer if you are not whatever. Two pointer stuff follow-ups. Okay, that's interesting. this one is the second question. They just build upon each other. Sparse matrix multiplication. Here is the current approach I use. I use multiply subroutine in this question to solve sparse. Okay. So, yeah, I guess that's true. You could use pairs. So self p is this. And then if x p append ix ij00 while n self p and j vec p length of that, then if self p I0 vec pj0 self pi1 times vec pj1 vec pj1 elif self pi0 vec pj then we just straight up return answer. It's kind of straightforward, and this should be way better, I'm guessing. Okay, so most people use this solution. That's interesting. Maybe if we do this, I don't know, I'm just guessing to gain a bit of time. Yeah, that made it slower, so it doesn't matter. It doesn't matter! As my guy John Cena says, that's even slower. Okay, Leetcode measurements are horrific. Okay, so we could just use a hash table, both vectors, and iterate over the smaller hash table elements, but that's not very cache friendly approach to store the arrays as pairs of index value at index. Use 2 pointers, one for each tuple array, and move them indices in both tuples are same. We add product of their values to the answer. Index in first tuple is smaller. We move first pointer index in second tuple is smaller. We second pointer on where n is nums plus vec . I mean, technically you have to, I mean, the speed is the same, technically. But if you do many queries, that's where, if you do many dot products, that's where it should be faster, right? Because I still have to construct it, so I still have to iterate over the whole thing. So, so on n nums, but n plus m, but theory, but the O1, no, O n1 plus n2 for query where n1 is the number of non-zero elements in nums and n2 is the number of non-zero elements in original array of vec. Note that if we do a single operation, a single dot product after construction, it's probably even slower than brute force, but it's way more efficient in real life if we do many dot product calls. O where O M per vector where number of non-zero values in nums, O1 per query, since we only use a couple of variables for the pointers and the answer. Okay, so basically to summarize, we can either use a hash map, right? We have vectors which mostly contain zeros. We want to do dot product. We don't care about zero positions no matter what's in the other array, because it's 0 times something is still 0. So we just want to represent somehow these positive numbers. The thing is that then we just have to store the positive numbers. We can do that in a hash map, and then we iterate over elements of one of the hash map and multiply, check if we store index as keys. So we would store at key 0 we have 1, at key 3 we have 2, at key 4 we have 3. Then we iterate over keys, and for each of them we check if it's here. So 1 is not there, 4 is not there, but 3 is there. So answer will be 4 times 2 is 8. Right, there is a follow-up question. If only one of them is sparse, meaning one of the maps is way larger, then we just iterate over the smaller map. That's what we did in the beginning. Problem with this is that hash map stores randomly in memory, or not randomly, but it stores, it pre-allocates some memory and then it puts it in there randomly, let's say, or pseudo randomly. Problem is that that's not cache efficient, because when we pick an element, we actually get that element and the next few elements in that row. but since in hash map they are random, that's not efficient. But if we use an array and we put the tuples of index and value in there, then that's way faster, because we just iterate over same like this, only the positive ones, but they are stored in consecutive places in memory, so that's way more cache efficient. And basically we just have two sparse vectors, and we wanna, let's say we have one pointer to one sparse vector and another pointer to another sparse vector, and we just check indices, right? If indices of the elements are same, right, so in this then we add to answer and we move both. If it's smaller in the first one, we have to get to next element so that they are possibly equal with the current j element, right? And for example, in here we would have like 0, 1, 2 with values 1, 2, 3, and here we would have two elements, right? We would start pointer here, pointer here. Now this has index 0, so we would move it here. Now this has index only 1, which is smaller, so we move this pointer to here. And then suddenly we have, oh, they are pointing to tuple with same index, so we multiply their values and then we move both pointers. But this one is already out of range, so we don't care about this, and that's it. So, and follow up, what if one of them is sparse? That means that we will have to move pointer in one of them way longer. So for the larger one, we just do binary search, because we just want to find the first position for which the index is larger than, so let's say I am here and I want to find the largest index of a or smallest index of a tuple that has at least the same index, so at least 1. Well, that's not it, and that's this, right? And if nums1 would have 1 billion elements, right, then we want to do a binary search, right? So then it would be like, instead of like n1 n2 plus n2, it would be like min n1 n2 times log max n1 n2, something like that. Hopefully you understand. Goodbye.